Hey, welcome to lesson 3 of unit 6. This is actually the final lesson of unit 6. Nice short unit. We've got dot product today, and we're going to dive right into what dot product is. Okay, it's going to end up giving you a scalar, so it'll be a number that you can multiply by. Okay, we start off with u as u1, u2, and v as v1, v2. If we want to know the dot product between these two vectors, we take u1 times v1 plus u2 times v2. So that's how you find the dot product. Then you got some properties of dot product. Like, for example, if we are doing u dot v, it's the same as v dot u. If we're doing the 0 vector dot u, it's going to give us 0 automatically. If we're doing u dot v plus w as vectors, we're going to end up being able to distribute and doing the dots separately. Here, if we're doing v dot v, it's going to be the magnitude of v squared. Kind of an interesting one here. And then this one's also pretty interesting, right? If we have scalar times the u dot v, we can distribute that c to one of these two, not both, right? So normally we'd think, oh, okay, distribute. Not the case here, because this is kind of like multiplication in a way, the way that we would treat it, so we don't want to distribute it. It's just going to happen to one of these two. Okay, so we are going to have some problems first, just asking us to find the dot product, and then underneath, you can't see it quite yet, you're going to have some that are using some of those properties. So let's do some finding the dot product first. They're pretty simple, right? We're going to take our first term times our second first term, right? These would be our firsts, v1 and u1. Then we're going to add the seconds, multiplying each other, right? -2 and 5. So this gives us 15 and -10. That comes out to be 5, right? So dot product really not that difficult to do. Let's try another one. -3 times 8, right, our firsts, and then -6 times 1. Those are our seconds. When we add, or actually when we multiply, we get -4 plus -6, and then when we add, we get -30. So you got one to try real quick. You probably don't even have to pause, but do it if you want. Alright, so let's see. 5 times -6 is going to be -30. 11 times 7 is going to be 77. And if we add those, we get 47. Not bad. Now we've got some with these properties. Okay, the properties are right here at the top. If you need to write those down real quick, go for it. Here we go. We've got u dot v times vector w. So what they suggest for us to do first is to figure out u dot v. So let's see, we've got 1, -3, dot 2, 6. And I'm going to keep w separate for right now. Let's see. That's 1 times 2 plus -3 times 6. That's 2 minus 18. I'm going to start substituting in w now. Alright, that's what they gave us for vector w. So let's see. 2 minus 18 is -16 times 5, -4. So let's see. -16 times 5 is -80. And -16 times 4 is going to be positive 64. Okay, so dot product, really nothing bad. We did that first, right? Figured out what we got for our scalar, and then multiplied times vector W. Right, and we didn't have to really write in all of W stuff until we really needed it. Okay, for the second problem, again, we're going to do the dot product first, and then we'll multiply by our scalar afterwards. Right, so for W, we've got 5, and for V, we've got 2, plus negative 4 times 6. Right, that's doing the dot product of V and W first, and taking this 2 out to the side for right now. Let's see, 10 plus negative 24, so 2 times negative 14, we get negative 28. Hey, that's kind of neat. Here we got a vector as a solution. Here we got a scalar. So it depends on what you're working with. You could get either one. You got one for yourself to try. So pause the video and resume when you're ready to check your solution. Alright, let's see how you did. This is what I would have suggested. Let's distribute u dot v and u dot w. So I'm going to do u dot v first, so 1 times 2 plus negative 3 times 6. Then we've got to do uw, so 1 times 5 plus negative 3 times negative 4. Let's see. 2 minus 18. And here we've got 5 plus 12. 2 minus 18, that's negative 16. 5 and 12 is 17, which gives us 1. So hopefully you got 1 as a solution there. Right, dot product, pretty easy to do so far. Here's something that we can do with dot product. Okay, the angle between two vectors. Right, so imagine that you have one vector going this way and another vector going here. Right, we want to figure out the angle between the two. That's what we're looking for. So this involves a little bit of trig, which is nice because this is a trig unit. So let's check out how it works. Right, something to note is that our theta, our angle, will always be between 0 and pi if we're in radians, or 0 and 180 if we're in degrees. Okay, we're going to be working in degrees for these particular problems, so make sure that you have your calculator set in degree mode. Here's the basic function, right? Cosine of an angle is going to be equal to u dot v over the magnitude of u times the magnitude of v. So basically what's going to happen is we're going to figure out what this is as a fraction, then we're going to do cosine inverse, and that'll give us the angle between. And we're going to notice hopefully that it always is between 0 and 180. So this problem right here, they want us to find the angle theta between u at 5, 6 and v at negative 3, 2. The formula says cosine theta equals u dot v. So 5 times negative 3 plus 6 times 2 over the magnitude. Magnitude is square root 5 squared plus 6 squared for u times the square root negative 3 squared plus 2 squared for v. So this is all the stuff that they asked for in the original formula right here. So let's see. That's negative 15 plus 12, 25 plus 36 times, let's see, 9 plus 4 We're getting somewhere, I guess, right? Cosine. If we bring all this stuff up here, so negative 15 and 12 is negative 3. 25 and 36, that's 61. 9 and 4, that's 13. And let's see, we're multiplying two radicals, so I can just multiply what's inside. So 61 times 13. If I multiply those, we get square root of 793. So this is what we came up to as a fraction. I'm not going to worry about radicalizing or rationalizing rather the bottom, because I can type this into a calculator and it will still handle it. So I'm going to do cosine inverse of negative 3 over square root of 793. That's what we're going to type into our calculator. Again, we want to be in degree mode, so make sure that you're in degree mode here. So let's see. Cosine inverse of negative 3 divided by square root of 793. And it comes up with 96.115. They want it to the nearest hundredth, I guess. It doesn't actually say. So let's see. If we round up to the nearest hundredth, that 5 tells that 1 to round up to a 2. So 96. Oops. 96.12 degrees. So visually speaking, right, this is what we got here. 5, 6 is up here. Negative 3, 2 is over here. And the angle that we just found between them is 96.12 degrees. And we use trig and dot product to find that. So you've got one for you to try on your own. You're using this formula, right? So hopefully you have that handy. You can use this problem above as a reference. Pause the video and resume it when you're ready to check your solution. All right, let's see. We're doing cosine. Theta equals to the dot product, so negative 5 times negative 1 plus negative 4 times 7 divided by magnitude. Oh, this is kind of a doozy, huh? Oops, that's not plus, that's times. A lot of stuff happening in that one. Let's see. Negative 5 times negative 1 is positive 5. That's going to be negative 28. Let's see, 25 plus 16. And that's going to be 1 plus 49. Cosine theta equals, let's see, 5 minus 28 is negative 23. 25 and 16 is 41. 49 and 1 is 50. If we multiply these, 41 times 50 is 2050. This is what we're going to be typing in. Cosine inverse of negative 23 over square root of 2050. If you type that into your calculator and round to the nearest hundredth, I know it didn't actually say what to round to, but here's what we come up with. 120.53 degrees. I'm going to just real quick make sure that that's correct on my calculator. Let's see, we had 23. Yep, got the same answer. So, we can move on. We've got one more thing to check out here for this lesson, and it's kind of tying together the angle between and the dot product all at the same time. What this is telling us here is that if you do the dot product and you come up with 0 as your scalar solution, then the angle between those two vectors is 90 degrees. Now, if you want to know exactly why, that's something that I go over in class. I'm sure you can find that out on the internet, or somebody in the internet land can answer that for you in the comments if you're really interested. Okay, but that's something that I go over in class. So what you want to be working with really is right here. If you find the dot product equal to 0, then that angle is going to be 90. So you get questions like this showing up, right? Determine if the angle theta equals 90 between these two vectors, right? And all we have to do is a real quick dot product and see if we get 0 or not. Right, so I'm going to do dot product of u dot v. So we get 2 times negative 9 plus 6 times 3. 2 times negative 9 is negative 18. 6 times 3 is positive 18. When we add those, we get 0. Thus, theta equals 90 degrees. Okay, we came up with 0. If it's 0, then theta is 90. Okay, try a second problem. We want to determine if theta equals 90 between these two vectors. Right, so we got to do the u dot v thing again. Right, so 3 times 6 this time plus 4 times negative 8. 3 times 6 is 18. 4 times negative 8 is negative 32. When we add those, we get negative 14. That is not 0, so it's not equal to 90. I guess that's a sad answer. Okay, so that's all we're trying to do. It doesn't ask us what is the amount. I guess they could ask us to find it, but they just want to know if it's 90 or not. So you've got 2 here to try on your own, and then you're done with Unit 6. So try these 2, pause the video, and resume when you're ready to check your solutions. Alright, let's check them out. So we got to do u dot v, which is going to be negative 4 times 8 plus 8 times 6. Let's see, that's negative 32, and that's positive 48, which adds to 16, which is not 0. So that means theta does not equal 90 degrees. That was problem A. Problem B, we're doing the same thing. U dot v. This time we have 6 times negative 8 and negative 4 times negative 12. Let's see, 6 and negative 8 is negative 48. Negative 4 and negative 12 is positive 48. Things are looking good here, right? Those two give us 0 when we add. Thus, theta equals 90. Good news, bad news. All right, that's it for lesson number 3, and that's it for Unit 6, trig applications. So if you had any questions about what went on here, you can ask them. Maybe somebody out there can answer them for you in the comments, or you can bring your questions with you to class. All right, I'll see you at Unit 7. Bye.